All right, my pretty people. Here we go. We've got our third transformation called rotations. Now, rotation is when we take an object and then we spin it around a point. So we're going to spin it in degrees. So if you go all the way around in a circle, that's 360 degrees. So usually we're going to spin it in 90-degree increments around a point. So reflection was when you kept the same distance to a line and you just reflected across. Remember, our translations where you just take it and you just kind of move it side to side or move it up and down. Now we're taking the image and we're starting to spin it around a point. So this is our last transformation that we're going to cover in this unit. So it's like spinning around something. So here we go. Here I'm just going to do a point at this for right now. But here I've got point A, it's in quadrant 4-2. So right now it's at point 4-2, it's in quadrant 1. So I've got my quadrants here, quadrant 1, 2, 3, 4. I don't know why they're done backwards in counterclockwise. Who knows? Might have to do with the Romans because this is all Roman numerals. Blame them. Anyways, so I'm going to start rotating it. Now, I can do 90-degree counterclockwise or 270 degrees clockwise. They would be the same thing. So 90 degrees means I would move it 90 degrees. And so anything in quadrant 1, counterclockwise, 90 degrees would show up in quadrant 2. If I decided to rotate the other direction clockwise, 90 degrees clockwise would be here, 180 degrees clockwise would be here, and 270 would be here, because remember 360 gets you back to where you were. So we're just doing it in 90-degree increments. So a 90 degrees this way is the same thing as 270 degrees this way. All right, so I'm going to take this point and get it over here. What we're going to do is we're going to be rotating around the origin here, just to make it easy on ourselves. So this is going to be the point of rotation, and I'm going to start spinning this to get my image in the right spot. So how do we do this? Well, you can just spin your paper, really. So if I take this and spin my paper 90 degrees, there, I've just spun my paper 90 degrees. Now we're going to pretend like this is now the second quadrant. So this point, where would it be? Well, back 2, so negative 2, up 1, 2, 3, 4. So negative 2, 4 is where that point would be when I've spun my paper 90 degrees. All right, let's come back to here. Negative 2, 4. Negative 1, 2, up 1, 2, 3, 4. There's my A prime. And that is at the point negative 2, comma 4. Now, let's look at our X's and our Y coordinates. This one was 4, 2. This one was negative 2, 4. So what's happening here? Well, it looks like my Y value was 2, and then it moved to the X spot and became negative 2. So we're taking our Y and moving it to the X spot, but then changing its sign. So the 2 over here in the pre-image moves to the X in the image and changes its sign. So Y moves to X and it changes its sign. Now let's see what happens to the X coordinate. X starts off at 4 and it moves to the Y coordinate and just stays 4. So it looks like the X moves to the Y spot and keeps its sign. So a 90-degree counterclockwise rotation would be negative Y, comma X. Okay, now let's see what happens at 180 degrees. 180 degrees, counterclockwise and clockwise is exactly the same thing. So you can just say 180 degrees because it doesn't matter which direction you go. So let's take our paper and let's spin. Don't get dizzy. Let's spin 180 degrees. Well, I'm going to spin it 90 first. So there's 90 degrees. There's 180 degrees. Yay! So I have now spun it twice 90 degrees. So now we're at 180 degrees. And here's my new point. And my point appears to be at negative 1, 2, 3, 4, negative 2. So negative 4, negative 2 when I spun it 180 degrees. So negative 4, negative 2. So let's find that. So I'm going to go negative 4, so back 1, 2, 3, 4, and down 1, 2. I'm going to call this A prime prime, just so it's different from A prime. So now I am at negative 4, comma, negative 2. Now let's see what happened. My x was 4, my x became negative 4. Ooh, that looks like the x just changed its sign. So negative x. The y started off at 2, and then the y became negative 2. Looks like the y is just changing its sign too. So the coordinate notation for a 180 degree rotation is negative x, comma, negative y. Now this actually makes sense, because remember what happened up here when I went 90 degrees. When I went 90 degrees, the x went to the y went to the x, and changed its sign. Now let's take this 90 and then go another 90. So the x, this is the x right now, goes to the y. So negative y goes over here to negative y. And then the y, which is now the x coordinate, goes to the x coordinate and changes its sign. So x moved to the x coordinate spot and changed its sign. So we just did two 90s. I took this one, went 90, and I took this one and went another 90. Every time you go 90, you switch the x and y, and the y changes its sign when you move it over there. So we would expect the same thing to happen if I went 270. This moves to the x spot and changes its sign. So negative y would move to the x spot and change its sign, so that would become positive y. And then the x moves to the y spot and keeps its sign. So right now we have negative x, it's going to move to the y spot and keep its sign. So the coordinate notation for 270 degrees, because it's just another 90 degrees, should be y negative x. Let's see if that's right. So we said that 270 counterclockwise would be the same thing as 90 going the other direction. So let's just go 90 the other direction so we don't have to spin our paper so much and get dizzy and get sick and stuff like that. So anyways, I'm going to put my finger here and I'm going to rotate it 90 degrees clockwise. Woo! All right, there. I have just rotated it 90 degrees clockwise. So where should my original point show up at? It should show up at 2, negative 4. 2, negative 4. All right, so spin it back to where it's supposed to be. 2, negative 4. 2, 1, 2, 3, 4 would be right here. I'm going to call that A prime prime prime. 3 primes. And we said that this is the point 2, comma, negative 4. Now look at the coordinate notation. The y value moves to the x value spot. So 2 and 2, and they don't change the sign. The x moves to the y spot and changes its sign to negative 4, just like we expected to happen in our coordinate notation right over here. Yay! All right, so now we're going to just do 3 examples real quick. I'm going to rotate this one 90 degrees counterclockwise. So since A is in the second quadrant, we would expect A to show up in the third quadrant. Since B is in the third quadrant, we would expect B to show up in the fourth quadrant. Now, notice what was happening here when I was doing 90 degrees is the X and Y were changing their places. So the X was going to the Y and the Y was going to the X, and then the signs were changing too. But here's the thing. I already know which quadrant A should show up in. A should show up in this section right here. So I can still spin my paper and go, oh, that's going to be negative 1, 3. I can do that, but I already know kind of the pattern that's happening here, and the X and Y's are changing. So if I know that this is at 3, 1, or negative 3, 1, sorry, I know the X and Y's are going to have to change, and it's going to have to show up in this quadrant down here. So if I just switch these and ignore the negatives for right now, This would be 1, 3, right? Well, 1, 3 in this quadrant would be 1, 1, 2, 3 right there. There's my A prime. So what I did is I ignored the negatives because I know which quadrant it's going to show up in. The negatives are just there to show us which quadrant we're going to be in. And so I know in 90 degrees, we're just flipping the X and the Y. So B, we know should show up in this quadrant. Well, what's B? That's 2 and 2. So flipping it, it'd be 2 and 2, but in this quadrant over here. So there's B prime. Again, you can just spin your paper, or you can use the coordinate notation. I use this last shortcut. I just go, okay, what quadrant should it be in? Okay, let's flip the numbers. Now, what you notice here is the slopes. This one goes down 1, 2, 3, and over 1. So that's down 3 over 1. This one goes up 1 and over 3. 1 over 3. Ooh, these are weird slopes. It looks like we're changing the numerator and the denominator, so we're taking the reciprocal, and then this one's positive, this one's negative. So we're changing the numerator and denominator, and then positive, negative. Well, that's exactly what happened over here. Look, the x's and the y's change the sign, and isn't the slope just the change in y and the change in x? So that's what's happening here. And look, the negative, see, changing its sign right there. So the slopes are behaving like the coordinate notation, where we're changing the x and the y and a change in sign for the slopes. Also notice that, look, this is perpendicular. This is making a 90-degree angle. If I were to draw out this line and this line, they would cross each other at a perfect 90 degrees. Why 90 degrees? Because I just spun my paper 90 degrees. That's why it works. That's a bell, but that's okay. Moving on. Rotating 180 degrees. Now, our rotation of 180 degrees, we said all that changes is the x and y's change their sign. Now, I know that A should show up in this quadrant. A right now is at 3, 3 over here, so I should go 3, 3 back here. It's just changing its sign. There's A prime. For C, C should move over 2 quadrants. So C should show up in this one, 1, 3, 1, 3. There's C prime. B is in this quadrant, so it should show up in this quadrant when I rotate it. 2, 1, 2, 1. Because in our coordinate notation, the x's and the y's stay in their correct spot, they just change their signs. And if you compare the coordinates, you can see that there are still changing just their signs, because this was at -2, 1. This one is 1, -2. All that's happened is they've changed their signs. Now on this one, what we notice is that the slopes are not opposite and reciprocal like that last one. This one's going down 2 and over 1. This one is also down 2 and over 1. The slopes have stayed the same, but the facing of the object is different. Because remember, in translations, the slopes stayed the same, but the facing was exactly the same. In a rotation 180 degrees, the slopes change, but the slopes stay the same, but the facing is what changes on this one. All right, 90 degrees clockwise. So if I go 90 degrees clockwise, A should show up. Right now, A is between quadrant 2 and 3. So if I go 90 degrees this direction, it should show up between quadrants 1 and 2 instead. So if I go 90 degrees, remember, we're keeping our same distance to this point of rotation. So A is 1 unit away. Over here, A prime should still be 1 unit away. Because when we rotate, we're keeping the same distance to the point that we're rotating around. So A and A prime are still the same distance away from that point of rotation. Now B is in this quadrant. I would expect that B would show up in this quadrant next, because we're going 90 degrees clockwise. Now this is 1, 3, so I should expect it to be 3, 1, and be right there. Again, you can use the coordinate notation if you want to find out where your points should be. For instance, we know that a 90 degrees clockwise rotation should give us the coordinate notation of y negative x. So if I start off with B, B is at 1, 3. So here, y, that would be 3. So this is my y. So that's going to be 3. Negative x. Well, x is 1, so it's going to be negative 1. And that would be B prime. 3, negative 1, 3, negative 1. There we go. So the coordinate notation tells us exactly where it's going to be. Again, notice this one is perpendicular to that one. Why is it perpendicular? Because I rotated it at 90 degrees. 90 degrees makes a perpendicular, two perpendicular lines. 90-degree angle right here. Boop, boop, right there. Good times. Oh. So much math. All right, that was a short one. You're welcome. All right, bye-bye.